about, I was trying to filter the, the tween 80 part of the data. And every time I do that, it just tells me there's 0 lines with that. So I was going to see if you know why.
I do. That tween 80 has a space in it. And so you're going to have to include that space and put it in quotes. Did you do that?
Yes.
All right.
Let me run it and just tell you what the exact thing is.
If you want to share your screen.
So it doesn't, yeah, I can do that. It doesn't give me an error, it just tells me 0.
Yeah, and 0, it's not giving you an error because it, let's see.
It's just down here.
Substrate in tween 80. Okay, do df3 $ substrate.
Just up here.
On just like line 21. Okay. Just a separate command. Okay. Yep.
Okay.
And then wrap that whole thing in unique.
Okay. And do I just put that in parentheses to do that?
Yeah, so unique and then put the whole thing in parentheses, or unique first, and yeah, and then parentheses. Perfect.
Okay.
Our studio actually does a cool little thing where if you highlight something and hit the left parentheses, it'll do parentheses around the whole shebang. Okay, there it is. Number 13, tween 80. Do you see the problem?
Yeah.
It's got a trailing stupid white space after the 80.
So I just have to put a space after the 80.
Yeah. Okay. Or what would be more appropriate would be to clean up that white space first.
Okay.
But go ahead and try to run 19 and 20 now.
Okay. That works there.
Yep.
Okay. So that unique, what exactly did unique do to tell me that that space is there?
Well, it gave you all the unique values that were found in that column. And so I just wanted to take a look at them and confirm my suspicion that you basically weren't spelling tween 80 right. Well, you were, but the computer thinks that it's got a space after it.
Okay, that makes sense. Thank you.
Mm-hmm. All right, if you'll stop sharing, I'll bring up my screen. All right. Everyone see that? The theory and the practice? All right. So this is what I want you to be able to do by the end of this class. This whole shebang here. We've covered importing. We've covered a little bit the basics of tidying. As we encounter things like stupid spaces afterwards, we'll figure out some tricks to do a bit more tidying. But you know what tidy format looks like, right? Every variable gets its own column. Every observation gets its own row. And then we've covered visualizing our data, right? And your ggplot skills are quite strong. I'm pretty impressed, right? What's basically left is possibly transforming and modeling. So like making your data fit a normal distribution, that kind of thing. If your data is really wacky, you may do a log transformation on it or a square root, okay? But that'll come kind of later. What I'm wanting to move into now is this modeling, and this is the statistics, okay? This is where we try to simplify a description of the relationship between our variables. And we do it with a little math equation. Okay. R makes it pretty straightforward for us, and so there's no need to be like calculating an ANOVA table with pen and paper or a t-test or any of that. There's just a command for ANOVA and one for t-test, and we'll learn how to interpret the results there. Okay. So this is what we think data science is, but this is actually the reality. Okay. In particular, the tidying, as Lacey's example just showed us, right? Oh, we're going to tidy this simple data set about BioLog plates, and we're going to get an idea of what microbes, what carbon sources these microbes are using. And nope, didn't quite work. Something's wrong. So there's more tidying. So tidying is 80% of what you do as a data scientist of any sort. Once you get it tidy and in a nice tidy format, and there's no stupid trailing spaces and all that, once all that's taken care of, the rest of your job is like 6 lines of code. It's a ggplot and then 2 little lines for your model. Okay, it winds up being pretty easy at that point. So as we transition into the modeling, and we'll do that kind of today, at least starting on it, keep in mind that this is an iterative process. We're going to find problems and have to go back to the tidying step and fix something up there and then come back and try it again. So we're doing this little loop until we get it right, and then presto, we've got results. Okay. So I'm in data course Zon as usual, and I'm loading 3 data sets today and 2 packages. Okay, first one, obvious, tidyverse. That's at the beginning of most modern R scripts. Second one is car. This is a statistics package, but what's nice about it is that it comes with these 2 data sets, MPLS stops and MPLS demo. Okay, so we're going to use those. We might not even get to them today, but might as well bring them up just in case. Okay, so give me a cartoon hand when you've gotten into your R project and have loaded these data sets. Bigger. One thing you might notice is that my read CSV is not read.csv. I've done an underscore. That comes in the tidyverse set of packages. It has some benefits, especially if you're working with really large data. It's much faster than read.csv. I don't care which one you use, but if you want to stay consistent with me, keep that in mind, that I did read_CSV. I just see one hand.
Yeah, I'm waiting for the car library to install.
Gotcha. Yeah, it's bigger than I expect every time.
Yeah, mine's still loading too.
Okay. Here's a fun little trick. I may have told you this already, but if you're searching for R in Google, I don't know if you're aware of this, but there's like a lot of things that have R in them, and so it's kind of hard. So if you put it in square brackets, that helps Google know that you're talking about the R computing language. Okay. So this package is to help us with our modeling. It gives us some neat tools for that. You can see that it's actually quite extensive. So people in social sciences, finance, they all use functions from the car. Today, if we get to it, all we're going to be using from it are these data sets until we get deeper into modeling.
Done.
About half of you have it. While we're waiting for the rest of people's car package to install, any thoughts, feelings, questions about the material so far? Big picture or detail stuff?
Sorry, I'm actually getting an error when I try to finish downloading it. Getting an
What's
error
it
that
say?
says failed to lock directory.
Failed to lock directory.
And then it says try removing users my name documents R4.02 library 00 lock.
Oh, are you on a Mac?
No, I'm on a PC.
PC.
Share your screen.
I have encountered this before, usually with a Mac, but if you actually go in and find that with your Windows browser and delete it, that will solve the problem.
Okay.
Delete it and then install car again.
Okay, let's see. It's in documents. Library. So just delete the 00 lock?
Yeah.
Okay.
Delete the exact file, or I think it's actually a directory, but delete the exact thing that they
Okay.
tell you to.
Let's see if this works.
And that should work. If not, I can stay a few minutes after class and troubleshoot that. And I don't think it'll be a big impediment if you don't have car right now, because I can save this code and send it to everybody.
Okay. Thank you.
Mm-hmm.
It's downloading still, so we'll see if it works. That worked.
Cool. All right. So I'm going to run all this. Control Enter. All right, so you should see something similar. We've got the BioLog plate data that you've seen before. We've got it loaded up here It's not in tidy format though. So we need to fix it up. How do we do that?
We've definitely the rows and columns, they're wrong.
What's that?
So the columns should be the rows should be the columns. That needs to be rotated with that one command we learned before.
I know what you're saying, but your language is a bit imprecise and means something different. So I'm going to stop you a little bit. Are you talking about just these 3 columns? Or all of them?
From what I can see, the variables appear to be rows right now, like the well and dilution substrate, and the data appears to be columns.
Well, let's take a look at it. I'm just going to click on df up here. Are you still worried about that?
No, there's something about glimpse that I didn't realize.
Glimpse is showing you the column name. That's what this $ is actually saying here. So here's the column sample ID, and it's just showing it to you across rather than down. Okay. So that's okay. But we have cleaned this one up before. We did it together in class. What was wrong with it?
I think we wanted to add the hours all in one column.
Yeah, hour 24 is not a variable. Time is a variable. So hour 24, 48, and 144, those need to be compressed into a single column. And then we need a column next to it saying, like basically a column that says, this is the time, whether it's 24, 48, or 144. And then here's the value or the absorbance. So what's my magical command for that?
Mutate?
Nope. If this isn't coming straight to your head, you're not practicing enough. Pivot longer. Remember? This is in wide format. Okay. That means it's too wide. We need to make it longer. So we're going to pivot longer. We're going to take df, send it to pivot longer, and we're going to tell it what? The variables. So starts with HR. Okay. And then we're going to say pivot longer, names from. What should the names come from? Wait, not names from, names to. What names do we want? Time. Is this ringing a bell?
Yeah, this wasn't last class, wasn't it? The one before that?
Uh-huh. And we can say names prefix equals HR underscore.
Do you know why when I put in like names underscore values underscore, it isn't giving me a prompt for?
Yes, It's because I was getting all fancy and using df like that. So if I first start out with df inside, then it's going to give us all of our. Okay. So here, all the explicit we want to compress are the ones that starts with HR underscore. Okay. The names for the new column, the names will be now time. The values will now be absorbance. And we're telling it to go ahead and get rid of HR underscore in each of those times. I'm going to say this is df long. So the number of rows, n row df, and df long. We've got 1,152. We compressed 3 columns into one, and now we have 3,456, which, if you do the math, is 3. Is that intuitive? We took 3 columns, basically stacked them on top of each other. So our data frame is now 3 times as long. If we had done 4 columns and compressed them, like if we had hour 296 also, then it would be 4 times as long. So we're making it longer. Okay. All right. Let's take a look at our values. We already found one. Lacey found a problem. What was it?
That there was extra space that shouldn't have been there.
Yep. In our substrate. Do you still see it?
In mine, is that what you're saying?
Yeah.
Honestly, I'm still catching up from.
Oh.
I haven't gotten there quite yet.
Okay.
Yeah, can you explain what's going on? Why are you dividing the 2 data frames?
This is to show you that the new one is 3 times as long as the old one.
Okay.
I'm going to put an exclamation point there because this is very exciting, right? This is like a little sanity check that I'm doing for myself here. Basically, I know that I took 3 columns. So stacking them on top of each other, it should be 3 times as long now. But I didn't tell it 3 columns exactly. I told it just every column that starts with HR underscore. Okay, so I want to see 3 here. If I see 4, then I know that I actually took 4 columns and stacked them. You don't have to do this. It's just kind of a demonstration. All right, I want you to be real comfy with pivot longer. This is very, very commonly used function. It used to be called gather, so in older code you may see gather, but it works the exact same way. This is because it makes sense to enter data like this, right? You go in at hour 24 and take your measurements. You're just going to enter them down all the way, all right? You come back a day later, take your measurements, you just start a new column. This is normal. It's like a very natural human way to enter data, but it's not how the computer wants it. Okay. So what the computer really wants is this, time and absorbance, since time was the variable.
Are there programs out there that make you data where it's friendly to R? Like Excel, you can pretty much, put spaces and stuff wherever you want. Has somebody made something that says, okay, it stops you when you start putting in data that R wouldn't like?
No, but, and we're going to get a little bit into this. I didn't want to take a whole class period for it. There's a feature called data validation in Excel. So I can say substrate here, time there, and I can go in and say data validity. And I can tell it what to accept, right? Whole numbers. Does it need to be a time, a list, all values? Okay. So I'm going to make a list of values. I'm not going to allow empty cells. I'm going to show the selection list, and I'm going to say it's got to be 24, 48, or 144. Okay. So now in Excel, if I try to type in 47, it says invalid value. It won't let me do it. And so this is kind of like a social control for people who are entering the data. If you have a chance to make this the worksheet that people enter data, you definitely should do this. You should validate your data. So it needs to be one line apiece. Data validity. (24, 48, 144). Okay. 23. No. 24. Yes, it will take that. Okay. And so that's a way to kind of get around it. There is not a feature that prevents you from having a space at the end unless you've done it this way and given them the options. We are going to design an experiment together in class next week, and we'll be making a spreadsheet for it. All right, who is not caught up to this point?
Honestly, mine keeps giving me an error again for the same reason as last time, but I can't figure out, because I'm in the correct working directory, but I'm thinking for the sake of the class, maybe I can just talk with you about it after or something, so
Okay.
we don't get held back.
All right.
Okay.
Follow along best you can in that case. I will provide all this code. I'll stick it up on Teams after class today.
Okay, thank you.
Yep. All right, so we fixed that. Does anyone have, if you run unique dflong substrate, does anyone have tween 80 with a space after it?
I do.
I do as well.
Yep.
Did you use read_CSV or read.csv?
Read dot.
Score.
Dot.
Okay, it should, read underscore should by default kind of take care of that for you, removing trailing white space. But we can take care of that. Okay, so string what is it? Flatten glue. There it is. String squish. str_squish. Okay. So this will remove any repeated white space as well as white space from the start and end of a string. Okay. So we can do df long substrate. Okay. That'll get rid of any like double spaces that are in there. If somebody did tween space 40, that would take care of it. It will also take care of any extra spaces at the beginning or the end. So I'm going to do that, even though mine was okay. I'm just going to reassign df long substrate. Oops. As the string squished version of df long substrate. Okay. So that should clean that up. Now it's time to do some visualization. After cleaning, this is always the first thing you want to do. So we did some cleaning and tidying. Say, clean up extra white space. And now some visualization. So let's take a look at this. I want to see absorbance over time for all these different samples and all these dilutions and all these substrates. That's kind of a lot, but let's see how much we can fit into one visualization. So df long ggplot, my aesthetics, x equals time, y equals absorbance. Let's do color equals substrate. Color equals sample ID. Then we're going to add a geom smooth. And a facet wrap as a function of substrate. Well, that's pretty ugly and didn't work. Did I spell absorbance right? Absorbance. That was our y-axis. Maybe geom point.
I know that before I put in the geom, the stuff after your sample ID, it's just giving me an X on there. So maybe it has to do with the initial line.
I see what's happening. It'll put our points, but they're all in these little categories. They're in categories, but time is actually linear, not categorical in this case. So we can't do a regression line across categories. So what do I need to do? Little extra cleaning.
So is the problem that they're factors right now? They need to be numbers?
Yep. So if I look at glimpse df long, time is a character. So I'm just going to say as numeric. So here, change time to numeric. So df long time is as numeric df long time. And as you can see, this is playing out in real time for you. Something was wrong, so we go back, do a little extra cleaning. This is the process. All right, so I run that. Now I can change geom point back to smooth. Okay. Tell me what you see in this plot. Are you learning anything about our different samples and their ability to use various carbon sources? Steven, got a hand.
That's just up from before. I'm thinking
Oh,
about
sorry.
that. It kind of does. Yeah, it does.
Looks like absorbance goes up over time.
For some of them.
For some, yeah.
Yeah. Not for water. Which is good because water doesn't have any carbon. This was just pure water. And so if we'd gotten absorbance there, that would mean that our water was contaminated. So that was our like negative control. So let's see here. For 2-hydroxybenzoic acid, the green and the blue appear to be going up over time, but not the purple sample, which is our wastewater. And I can't see Clear Creek, the red sample, in there. I'm guessing it's probably hidden behind the purple one. We might have to check on that. Same for D-xylose, green and blue going up over time. There's our two, Clear Creek and wastewater, not being utilized. Same for edeconic acid. Our soil samples are able to utilize this as a carbon source. Neither one of our water samples is. What could explain that to you as a biologist?
That describes the type of metabolism that the microbes have in that area, right?
Yeah, they've got different microbes inhabiting them, and so they have different biogeochemical potential, right? So it's looking to me like, at least in these two water samples, Clear Creek and wastewater, none of the microbes are capable of utilizing these substances, but in the soil, they are. Okay. In other cases, we see different patterns. Overall, it looks to me like maybe soil is capable of utilizing more of these carbon sources than the water samples. So I'm developing a hypothesis already just by kind of looking at my data. So let's get a bit closer on that. Let's combine the soil samples and the water samples together. How could we do that? How would we manipulate our data frame here using our fun little verbs that we learned to combine Clear Creek and wastewater, and then combine soil 1 and soil 2?
Isn't it the same thing we did with the hours, that we just pivot them into the same? No?
Nope. It's already in tidy format. I want a new column. I want to create a new column based on a function of the other columns.
So you
Mutate.
use
Is it
mutate.
mutate?
Mutate. So I basically want a new column over here to the right that says sample type. And I want it to say water or soil. How would I do that? Let me give you a minute to think about it.
I'm trying to get the plot to work correctly. Why isn't your sample ID there green? Didn't you put it in single quotes?
Oh, those are backticks. Remember? It's the same button as our tilde. It's just backticks. This is why you should never have spaces in your column names. So maybe that's confusing to me, and so I want to go back up and do some more cleaning. So I can look at names of df long. Oops. Sample have a space in it. How would I use square brackets to access just the first name in my data frame?
Yes, it does rows, columns. So you do just names. So just a comma, because names is a column, right?
Incorrect number of dimensions.
And then you put something there, like a 1 in one of them.
Incorrect number of dimensions. That error is telling us something pretty important.
Wait, don't you do 1, 1?
Incorrect number of dimensions. How many dimensions does a data frame have?
It's got 2.
2. It's got width and length. How many dimensions does the names of my data frame have?
Just 1.
Just 1. It's a vector. You can see it, it's just spitting it out here. It's got 1 through 7. So if I ask for the names of df long, it expects a single value in there. So the first df long, which is sample ID. Right. So if I wanted to get rid of that space, I can say sample ID like that. Do you see what I'm doing? I am reassigning the value of the first name in my data set to just be sample ID without a space. Control Enter on there. And now if I type in names df, names df long. There's sample ID without a space. Rep, well, dilution, substrate, time, and absorbance. If I go over here and click on df long to take a look at it, you'll see that the column name has changed from sample space ID to sample ID. So R is going to let us manipulate anything about our data frame that we want. It's just a matter of knowing how to access it. That's why square brackets are so handy, right? So we said, hey, name, because I know that's sample space ID, and I want you to call it sample ID. All right, so now my plot is not going to work. How come?
You could have changed that. Wait a minute. For the color, like the object sample ID is not found, so just delete that space.
Sample ID without a space.
Yeah.
Yeah. All right. This is something that people get hung up on or run into errors with, because we're often going kind of back and forth. We do a plot and we say, oh, I don't like this, or that needs to be cleaned up more. So we go back up and change something. That means we have to make sure that it's not changing stuff downstream. So now that I've changed that to sample ID without a space, I had to change it in my plot. Okay. So now that's working. Or I think it is. Yeah. Now, back to where we were, I want a new column in here. And I want it to be sample type. And I want it to be soil or water. So I can say df long mutate sample type without a space equals. Now how do I do this? I want R to look through this column, sample ID, and every time it sees Clear Creek, I want it to spit out water. That's a lot of Clear Creeks. Every time it sees soil 1, I want it to spit out soil. So how do we do that? Well, mutate has another little helper function. Called case when. This is basically just an if-then statement. Let's see. Come along now. Okay. So here's somebody who has done it. Mutate a new column name is equal to case when carb is less than or equal to 2, then it should be considered low. Let's take this format, copy it, paste it in here for reference, and see if we can do the same thing here. Case when sample ID is equal to or is in Clear Creek for waste water, then that should be water. When sample ID is in the vector soil 1, comma, soil 2, then that should be soil. So see how they've set that up? You're basically asking it a true-false statement. If it's true, it will give you that value. Okay. If it doesn't meet any of these, it'll return NA for you. So let's take a look at this. Looks like it's working. Clear Creek got the word water. So I'm going to just reassign df long to itself, but now with this new column. All right, so I'm going to walk you through it again. df long is now assigned as df long, where a new column has been mutated into existence. That new column is named sample type, and the values in that column should be either water or soil. So when sample ID is found in this combination, Clear Creek or wastewater, it returns water, comma. When sample ID is found in soil 1 or soil 2, it returns soil. So I'm going to run that. So now I can take my whole plot again, copy, paste it here, add some comments so I don't forget what happened, make new column based on sample ID for sample type, replot using sample type. So now instead of color equals sample ID, I'm going to change that to sample type, because that's a new column we got.
All right, of course, I'm getting some errors. It says there's a problem with mutate input sample type. Must be a two-sided formula, not a logical vector.
Okay. Case when sample ID in Clear Creek wastewater, that needs to be closed off. That doesn't get closed off. And this is a tilde.
Yes. So far I haven't matched exactly as you do. Oh, I have an extra parentheses at the end. Never mind.
Yep. It's all good. All right, this is easier for me to read now. We've actually combined all the values of the different soils and the different waters, and we're getting a better glimpse of what's being utilized here. Okay, so we've got soil versus water. It looks like in every case, the soil is utilizing more of that carbon than the water. Okay, as a scientist, if you see a graph and you say, it looks like A is bigger than B, what's your next step?
Proving it using stats.
Prove it. Yeah, I don't believe you, okay? I'm guessing so. It looks pretty real to me, but let's prove it. Okay. That's where modeling comes in. Okay. Which we don't have enough time to get into today, after all. So we'll pick that up later. But it looks pretty real to me. Okay, so this was a short example, really just a couple dozen lines of code, but it's half of the data analysis pipeline right there. I was hoping to give you a chance to kind of see the whole thing in action from start to finish, which is we import the data, we start cleaning it up, we visualize it, we find some errors, we go back and clean some more, we visualize it again, we realize there's some more errors, like we don't like sample ID having a space in it, so we do a bit more cleaning. Okay. And then we get to a point where we're visualizing things, it looks right, and now we're starting to think about our data and develop hypotheses in our head saying, to me, it looks like soil can utilize more than water can, at least in these samples. Okay. We put a little note here. Sample ID, column questions about, if you've got questions, technical questions about this, that's fine, but I'm more interested in kind of big picture questions about the process that we're going through.
Can you go back to mutate? Mine's having some problems. It says does not recognize sample ID as an object, which doesn't make sense because I spelled it right and everything. I'm trying to figure that out.
Did you run this?
Yeah, I think I did. When I go to dflong, I see sample ID and not what was there before. I'll run it again just to be sure.
Yeah, so in dflong, you should see sample ID, no space.
Yep.
Okay. Now, did you actually do dflong there?
1 second, did I delete? No, it's good. It's dflong.
All right, share your screen.
All right, so I will share it real fast.
In the meantime, anyone have questions about this process? The process of import, clean, visualize, go back and clean some more, that kind of thing. Okay, mutate, can't. All right, so go ahead and hit Control Enter on line 34. Don't highlight it. Yeah, don't highlight it. Just leave your cursor there. It worked. Do you see what the problem was? I think you were just highlighting row 34, or maybe just row 35.
Okay, I will try to highlight the whole thing again.
Yeah, highlight the whole thing, because it's a whole statement. Yeah.
Ow. Okay, that's silly.
That's fine. Yeah, you were just feeding it half of what you were trying to say.
All right.
All right, we got about 10 minutes, which isn't enough time for me to actually get in and do full joining with MPLS stops unless I rush it. I don't feel like rushing it. I don't think you're going to learn it that way. So we'll save that for next time. So questions about what we've covered so far with our dplyr verbs, our tidying.
Okay, I just want to make sure I have the last thing we did clear. So we have mutate, which is saying, hey, we're going to make a new category called sample type.
A new column.
Or column. So it's going to be a new column. And we're saying this new column is going to have in it under sample IDs, if it ever says clear creek or wastewater, just change that to water. And then the same thing for soil. Why do we use the tilde or whatever it's called instead of an equal sign when we're...
I have no idea. This case when was recently released, like in the past year, with the new version of dplyr, and I have not looked into the code, but that's just how they wrote it. To be confusing, I suppose. Let me just show you another way to see kind of, or another way to do what we've done. This might help understand what's going on in here. So I'm gonna go up here to 40 and do Control-Alt-B. It's gonna run all the code before, and so dflong won't have the new column in it. All right, so sample type is not there. I can say basically dflong $ sample type is, and just give it a blank nothing. It's an empty vector. So I've created that empty vector. It's not even showing up for me. That's handy. Okay. But it's there. df long $. Is it there? It's not even there. So I'll just call it NA. There's sample type. It's just a bunch of NAs. So I've created basically an empty, stupid vector. Now I'm going to fill it. Okay. So I can say df long $sample ID is in concatenate soil 1, comma, soil 2. And that's just a bunch of true false. All right, so I'm finding any rows where sample ID is found in this vector. All right, so then I can use that. I can say soil rows, and I can say df long sample type in square brackets soil rows is soil. And then just do this again for water. So water rows, wastewater or clear creek. df long sample type water rows is now water. All right, so I create a blank one. I find the rows where sample ID is soil 1 or soil 2. I find the rows where sample ID is clear creek or wastewater. And then I use those rows to set my values for sample type. So now df long, it's got sample type, and it's going to tell me whether it's water or soil. All that is longer and a bit more fragile, and I think less readable than doing mutate. Most of the code you see out in the wild is going to be in this format. It's not to say that this is wrong, but it's definitely a lot more typing, a lot more room for errors, and a lot more confusing to see what's going on. Here, we say we're creating a new row. It's called sample type. It's going to be either water or soil or NA. If sample ID is found in Clear Creek or wastewater, then it's going to be water because of tilde for some reason. If sample ID is found in soil 1 or soil 2, it will become soil. So now we can plot it. I'm going to go ahead. I'll leave this in and just comment it out the long, confusing way. So we've cleaned our data a couple times. Hey, where'd you go? There you are. Just to get this plot, it gives us some insight into our actual data set, maybe our scientific question, and that's how we decide what statistical tests we're going to be able to do on here. Does anyone have a hunch on what statistical tests we might want to use?
I'll just take a guess. T-test?
Great. Okay, t-test is going to look for difference between means. So yes, we could do that. We'd have to pick a certain point, though. We'd have to say at hour 144. There is a significant difference in the mean between these two groups. So to do that, we're basically going to have to subset our data. We could say df long filter time is equal to, what was it, 144? Yeah, 144. And then we'll just call that df 144. So now we can do t dot test. This is set up a bit weird. I hardly ever use t-tests. So it actually is going to want it in grouped format. It wants it back in wide format. So I will use analysis of variance, a one-way, which is a t-test. And I will say the data I'm using is df144. My formula is absorbance as a function of sample type. And I'll save that as mod 1. Summary mod 1. Is there a difference? Anyone who's had stats? P-value is almost infinitely small. So yes, they are different. Okay. Which makes sense if you just look at our plot here. Okay. They're different at least at hour 144. If I change that to 24, yeah, they're even different at 24 hours. Okay, so we could do several tests that way. All right, but that's just the beginning of the modeling that we're doing. All right. Once you get that, you're basically done, and you just present your data and say, here's my model results, here's the picture showing it visually. Okay. What I was hoping for today's kind of plan in my head was that, well, we'd get through a bit more to learn the join, but that's okay. I wanted you to see data being analyzed kind of in real time with me making mistakes and kind of trying to fix them, seeing what it's like to have to go back up and do some more cleaning, say, oh, I don't like sample ID having a space. That worked out perfectly, right? So we'll fix that and then we'll go and visualize it. Oh, our visualization is too crowded. It looks like soil and water are behaving similarly within their groups. So let's just combine them and see what happens. All right, so then we do a bit more cleaning and we change our data set to now have a new row or a new column that we use to visualize or to model with. So I'm hoping some of that came across. Following along with this, I was typing kind of fast, and if you're not putting in your 6 to 10 hours of practice, just seeing what mutate does, then it probably was going a bit fast for you. My advice would be go practice. And specifically, I've got the BioLog challenge here. And then see if you can put these two bits of code back in order. Okay. And then I think we're not quite ready for this. Yeah, don't worry about week 7 practice yet. Get really comfortable with these practices, go through all these resources, and see if you can figure out those errors that you're getting. It's probably going to be that you spelled something wrong or you're doing something wrong with your parentheses. Anyway, we're out of time. Lacey, do you still need to hang out after?
Nope, I figured it out. I just
Okay.
had to clean up a few things. So yeah, I'll just rewatch this whole lecture tonight or
Okay.
whenever it gets posted. Thank you.
No problem. All right, anyone else need anything?
When is assignment 7 due?
Let me double check to make sure I'm not messing with you. Oh, end of this week. So,
Okay.
yeah, I'll download it probably Monday morning. I'll do a git pull. Assignment 7, it's maybe a bit confusing. I'm giving you an R script that was written this way, this kind of like long, confusing way, where we do everything with base R, none of the tidyverse stuff. And I want you to take each little section. I've got them numbered just like this, like here's what I'm doing, and then I do it. I want you to recreate what I did, but to do it with using things like mutate, select, filter, that kind of thing. And so it's just basically you translating from the code I wrote into these tidyverse verbs.
Okay.
So you'll have the outcome to work with. You'll see what needs to happen. I want you to use the tidyverse verbs to get there.
Okay. So it's due before class on Monday?
Yeah.
Okay. Cool.
It's not too bad. It's a pretty short little script. And then at the end, I've got a for loop in there. I just want you to run that. I don't need you to like recreate the for loop or anything. Just run it. It makes a bunch of regression graphs, and I want you to try to interpret them. Okay.
Okay.
That's all. Because we're really close to starting to model, so I want you to start looking at regressions and kind of thinking about what they mean and what they don't mean.
All right. Thank you.
Yep. All right.